Hello. In this KORNCAST, we are going to talk about linear programming, and we're going to look at an example. Take a second and read this scenario. You can press pause if you need to, and then press play when you're done reading. Wow, that was a lot of reading. Well, there's a lot of information in here. Well, obviously we're dealing with a farm, and we're going to try to help the Smiths maximize their profits. We're going to make sure of how many acres of each type of something they need to plant. Well, the first thing you need to ask yourself, what are those somethings we need to plant? Well, the problem clearly states we're planting corn and tomatoes. And then there's a lot of information about corn and tomatoes. And so it's our job in linear programming to decipher all this information and analyze it the best way we can. So the first thing we want to do is we want to define what we're trying to find. Well, let's go ahead and define X to be the corn. And let's go ahead and define the Y to be the tomatoes. So the first thing you want to do is obviously decide how many acres of each type we should plant. Well, what are we trying to plant? Corn and tomatoes. So the first thing, identify the variables. Now what I've done is I've trimmed off a lot of the excess information. I got rid of the information about the Smiths and their limitations, and I just left all the stuff. So it's our job right now is to decipher all this information in a way that's easily to look at. Well, again, after we've identified the corn and the tomatoes, I think the easiest way to do this is to use a table format, or a spreadsheet if you will. I went ahead and made my corn one column, and my tomatoes the other column, and my total the third column. So now we need to decide what goes in the rows right here. Well, we have lots of things going on here. We have acres available for planting. We have planting. We have harvesting. So we have a lot of things to take a look at here. And I think it's really important that as you look through these things, don't try to mix one thing into the other. Make a separate row for each thing. So for example, let's make this one just talk about the land. And when we think about it, the land consists of two things, corn and tomatoes. If we have 10 acres of corn and 10 acres of tomatoes, then we have 20 acres total. But as we read through this problem right here, we know that if we read through this, that we have a total of 21 acres available for planting. So the first thing I would do is I would highlight important information. For example, this is pretty important. So I know that my total land for this problem right here is going to be 21. So the first thing I do in my little table is I just fill out all the appropriate information. Corn plus tomatoes, total of 21. So once I've got that one taken care of, now I need to go ahead and add another row. And what is this row going to talk about? Well, let's read through the problem here. What else is we have here? We have a total of 150 hours available for planting. So that should be our next thing. So let's go ahead and write planting here. And we know that we have a total of 150 hours for planting. Okay, so let's go ahead and keep reading, and let's find all the information that talks about planting. Well, each acre of corn takes 6 hours to plant. Okay, and 4 hours to harvest. But harvest doesn't have anything to do with planting, so I'm going to skip that. Each acre of tomatoes takes 10 hours to plant. So there we go. And then I'm going to, again, omit the 10 hours of harvest because harvesting has nothing to do with planting. So now I need to decide what do I put in here. Well, I know if it takes 6 hours to plant, and if I have 2 acres, that's going to be 12 hours because 6 times 2 is 12. So if I know it takes 6 hours to plant, then I'm going to have 6x in here for my in this little part of my table right here. And same thing goes with my tomatoes. I know if I have 10 hours and I plant 5 acres, well, that's going to take me, you guessed it, 50 hours. So I'm going to go ahead and do 10 times y right here. Okay, now as we mentioned before, we have one more thing to deal with. And as I read through the problem, I know that I'm going to have 130 hours available for harvesting. So the last thing that we need to talk about is harvesting. So the last thing in our table is going to be the harvest. So as I keep reading, I know it's going to take 4 hours to harvest my corn, and it's going to take 10 hours to harvest my tomatoes. So now once I've identified all the things that have to do with harvesting, well, the same thing applies right here. It's going to take me 4 hours to harvest corn, and that depends on how many acres I have. If I have 10 acres, it's going to take me 40 hours. So I have multiplication again. And same thing over here with my tomatoes. I'm going to have 10y, and my total is going to be 130. So I think the best thing to do is use a highlighter and highlight important information. And again, go through and make sure that we put a label in each one of these rows right here. It's really important that we don't include harvesting in the land part or planting in the harvest part, because really they're independent of one another. So please make a scenario for each independent thing. Okay, so now what do we do with our constraints right here? Well, what we know is that in order to, in our total land right here, we know that we have corn and tomatoes. So it's really easy to understand that if we add the acres of corn plus our acres of tomato, we're going to get our total acres. However, we know that we can't plant more than 21 acres because it's not possible because we don't have more than 21 acres of land. But let's say we only wanted to plant 5 acres of corn and 5 acres of tomatoes. Is that okay? Would that fit in our land? You bet. So what we'd end up with here is an inequality. Our total amount of land has to be less than or equal to 21 acres. And that's because we can plant less if we want to, but we can't plant more. So the first constraint for this particular problem is going to be x plus y is less than or equal to 21. Okay, well the same thing is going to happen with planting. I know that the number of hours for planting corn plus the number of hours planting my tomatoes cannot exceed 150 hours. It can be less. I could get the job done early, but I know that I can't go over that. So that's going to give me my less than or equal to inequality again. So that's going to give me 6x plus 10y is less than or equal to 150. And the same thing is going to happen with my harvesting. My time harvesting corn plus my time for harvesting tomatoes cannot exceed 130. So then we get 4x plus 10y is less than or equal to 130. And then those are our constraints for this particular problem right here. Now there's a couple more that I want to talk about. I call them well duh constraints. And what I mean by that is that there's a couple of common sense things that we must address right here. For example, can I plant negative values of corn? No. So my corn has to be greater than or equal to 0. So now my corn is going to be all values bigger than or equal to 0. I could plant no acres of corn, that's okay. I can plant 1 acres or 2 acres, but I can't plant negative values of corn. And the same thing can be said for my tomatoes. I cannot plant negative acres of tomatoes. And it's important that we graph these two well duh constraints right here, because if not, we will get an unclear feasible region right here. So it's really important that we add these common sense inequalities to the problem. Okay, now what we want to do is we want to graph our constraints. And I'm going to put all 3 of these into slope-intercept form. So the first thing I'm going to do on this one is subtract an x from both sides. And that's going to give me y is less than or equal to negative x plus 21. And that was pretty easy. Okay, the next one I'm going to subtract a 6x from both sides. And that's going to give me 10y is less than or equal to negative 6x plus 150. Next thing I must do is divide both sides by 10. And I must remember that when I divide by 10, I need to divide everything by 10. So I'm going to get negative 6/10 times x plus 150 divided by 10. And then, of course, reduce the fraction. So y is going to be less than or equal to negative 3/5 x plus 15. On this side over here, okay, last one, subtract a 4x from both sides. So I'm going to get 10y is less than or equal to negative 4x plus 130. Just like last time, I'm going to divide everything by 10. And then I'm going to get y is less than or equal to negative 4/10 times x plus 130 divided by 10. And then last but not least, I'm going to get y is less than or equal to negative 2/5 times x plus 13. And what I end up with is 3 inequalities, solved for y, so they're in slope-intercept form, so they're going to be pretty easy to graph. And I'm going to be also left with my 2 common sense constraints. And so in order to get my feasible region, I'm going to graph these 5 inequalities. Okay, let's take a second to graph our constraints now. In this first inequality here, our y-intercept is 21, and our slope is negative 1 over 1. So that means we're going to go down 1, right 1, down 1, right 1, down 1, right 1. And this pattern will continue obviously down until we get down here to a y-intercept, or excuse me, an x-intercept of 21. So that would be the points for that problem right there. Once we've established our points, now let's go ahead and take our ruler and draw our line that fits those points right there. Now let's take a second and talk about the shading. Since y is less than or equal to my x values, my shading for this particular problem is going to go below. But instead of shading all of them, I'm just going to draw arrows to indicate where the shading is going to go, so I don't have too much shading going on here. Okay, the next one has a y-intercept of 15 and a slope of negative 3/5. That means I'm going to go down 3, right 5, down 3, right 5, down 3, right 5, down 3, right 5, and last one down 3, right 5. So now I have my points there. So now I'm going to take a second and draw my line of fit there. And then again, y is less than or equal to my x value, so my shading for this one is also going to go below that line right there. Okay, the next one, the y-intercept is 13. And the slope is going to be negative 2/5. So I'm going to go down 2, right 5, down 2, right 5, down 2, right 5, down 2, right 5, and down 2, right 5. So again, once I have my points, I'm going to take my ruler and draw my line of fit. And again, y again is less than or equal to x, so my shading for this one is also going to go below that line. Okay, the next two are our special cases. X is greater than or equal to 0, so that tells me it's going to cross the x-axis at 0. And so I know from my special cases that this is going to be my vertical line up and down at x is 0. And says x is now greater than 0, so all my x values greater than means my shading is now going to go to the right. And then last but not least, my next special case, y is greater than or equal to 0, which means it's going to be a horizontal line crossing the y-axis at 0, or it ends up being my my x-axis. And just like last time, the shading y is greater than 0 means I'm going to shade above. So now there's about 5 inequalities there, and we have shading going all over the place. So I'm going to start inside here, and I notice that this line right here, all the shading is below right here. So I'm going to go ahead and shade below that. And then at this point right here, I notice that I have this little line segment. So the shading is going to be below that line segment right there. And then at this point right here, it takes another turn, and now our shading is now going to go down to this point. It's going to be above the x-axis, so my shading is going to be above that. And it's to the right of the y-axis, so my shading is obviously going to be to the right of that. So what this does is it creates my feasible region. And so again, our feasible region means everything inside this shaded blue area right here is going to satisfy all 5 of these inequalities at the same time. Okay, once we've graphed our constraints, our objective obviously is to find the vertices. And again, the vertices give us our optimal solutions. And I think on this particular problem, how we graphed it, if we take good care in graphing this, we get our feasible region here. And again, our feasible region are all values that satisfy our constraints. And again, the best ones are the vertices. So I think it's pretty easy to tell by inspection that our vertices are pretty easy to obtain. And so what I mean by inspection is we can tell, especially if we graph properly, that we can get our vertices by looking. So our vertices from looking give us 0, 0, 0, 13, 10, 9, 15, 6, and lastly 21, 0. So now once we've found our vertices, now it's time to test these vertices in our objective function. So once we've identified our vertices, now it's time to take a look at our objective function. Now let's refer to the last sentence in our situation. We know, just by reading, that our acres of corn can be sold for $600, and our acres for tomato can be sold for $800. So now we want to answer the question, how much each type should the Smiths plant? Well, so let's go ahead and think about this as a profit equation. We know our profit's going to equal. Now, if we harvested 1 acre of corn, we're going to get $600. Same thing if we harvest 2 acres of tomatoes, we're going to get $1,600. So to set up our objective function is pretty easy. I know our corn is X, so it's going to be 600 times X. And same thing's going to happen with our tomatoes. We're going to multiply our Y to our tomatoes. So our $800 is going to be multiplied by the number of acres we produce. And then to get our total profit, we're going to add those two together. So the objective function is actually pretty simple to do. Now it's really important to keep this one completely separate from the other ones, from the constraints, because this is the only one that's really talking about profit, money. Okay, so once we get our objective function and we've got our vertices, now we can go ahead and test our values. So from our graph, we have 0, 0, 0, 13, 10, 9, 15, 6, and 21, 0. So let's go ahead and test our values now. So we're going to have 600 times X, well X is 0, plus 800 times Y, which is 0. And this one's pretty easy to determine that if you don't plant any corn or any tomatoes, you're going to make a profit of $0. Okay, the next one, we're going to have our 600 times 0 plus 800 times, instead of Y, we're going to have 13. And that product in sum is going to result in $10,000 and $400. Okay, the next one, we're going to get 600 times 10 plus 800 times 9. And that product in sum will result in $13,200. Same thing with the next one. We're going to have our 600 times 15 plus 800 times 6. And that product will result in $13,800. And last but not least, we're going to have 600 times 21 plus 800 times 0. And that will result in $12,600. Okay, so by inspection, we now can determine that this point right here, 15.6, gives us the largest value of our objective function right here. So that's the winner. And what this is saying is that if we plant 15 acres of corn and 6 acres of tomatoes, we're going to maximize our profit, which is the whole point of this particular linear programming problem. Alright, so here's how we want to write the final answer. Once we've determined that we got $13,800 as our best answer, We now want to write our answer in a complete sentence. And I know it's a big task to write a sentence, but it means that you have to interpret the problem a little bit. Since this is our X, and X was talking about corn, well, our farm should plant 15 acres of corn. Since our 6 is our Y value, which is tomatoes, then we should plant 6 acres of tomatoes. And we want to obtain a maximum profit of, well, what did we get? $13,800. So again, please make sure we write our answers in proper form right here. Our answer should include both our X value and our Y value, and obviously indicate how much money we made off that little endeavor. So again, please write your answer in a complete sentence. I like capital letters and periods myself, but that's just, I don't know, how I like to write my complete sentences. And hope you enjoyed this particular KORNCAST.